So welcome back after a 4-week break for the Christmas and New Year holiday. So at the end of the last lesson, we were just about to start circle theorems. And I sort of gave you a bit of a Christmas holiday task, didn't I? Which was to make sure you know the names of all your circle parts because they are essential learning or essential knowledge for today's lesson. So I'm really hoping you've gone away and done that. I'm hoping you know all of your circle parts. If not, commit that to memory really quickly because I'm going to start today with an ABCD quiz on circle parts, okay? So the names of the circle parts. If there's any you don't know, it's a quick way of just finding out what you do and don't know. And then we can move on because we're going to use some of these names today in the circle theorems, okay? So circle words. So the length outside, around the outside of the circle. So essentially this green line, can you see this green line going around the outside of the circle? Is it B, A, diameter, B, circumference, C, radius, or D, arc? And I'm going to give you a chance to tell me whether it's A, B, C, or D now. If you don't know, just have a guess, and then I'll tell you the right answer in a minute. And, oh, brilliant, we have got 100% on circumference, so that's a really good start. People have been learning their circle words. Well done. Okay, what about this red line across the middle then? So this is the line that goes all the way across the middle. It goes through the center, and then from the one end of the circumference to the other end of the circumference. Is it A, radius, B, chord, C, tangent, or D, diameter? You can vote. Hang on, you can vote now, I think. There you go. Brilliant, 100% correct. The correct answer is D, diameter. Well done, everybody got it right. Doing really well. Got 2 out of 2 so far. Let's go a bit quicker then. So from the center, from the middle of the circle to the outside, is it A, the radius, B, the chord, C, diameter, or B, a bisector? Okay, we'll talk about what that word means at some point today because that's quite useful actually. Here we go. Take your vote, A, B, C, or D. Brilliant. We have got 100% correct on every single one so far. So you are just doing amazing. Just to quickly go through, a bisector is simply something that cuts something in half. Okay. So we will actually talk a bit about how a radius actually bisects, or I better not use that word because you're going to have to use it in a minute. So we'll do that in a minute. Let's just carry on with this for the moment. Oh, half of the diameter, no diagram for this. Half of the diameter is the A, width, B, height, C, radius, or D, circumference. Vote now for me, please. Half of the diameter is the radius. Well done, 100% correct on that too. Fabulous. We're doing really well in this, this one today. Okay. All right, here's the word that I was looking for earlier. What is this? It is another straight line that goes from one part of the circumference to the other, but it doesn't go through the center. Okay, so it's different to the one we used earlier. What's this called? Is it radius, diameter, bisector, or chord? Cast your votes now for me. Fabulous. I think we did talk about that one in the last lesson. I think someone asked about it. So you all got it right. So that's great. It is a chord. Okay, so that is the correct word, the correct mathematical term for a line that goes straight through the circle from one part of the circumference to another that doesn't go through the center. The diameter, which does go through the center, is technically also a chord, okay, because it goes from circumference to circumference. So it is technically a chord, but we don't tend to call it the chord because it's got a special name because it goes through the center, so it's a diameter. But a chord is basically just anything straight line that does that. Okay. And I was going to say earlier that a chord bisects a radius. So if you've got a radius and a chord and they meet, they bisect each other. So we'll look at that at some point later when we look at doing circle theorems, because that's a really useful thing. It's not technically a circle theorem, but it's not one that I've actually got to do today, but it is useful to know. So that's just an extra fact for you. Okay, what is this? So is this A, a sector, B, a fraction, C, a slice, or D, an angle? Brilliant. Well done. I thought we were getting harder now, but you've got 100% on this one as well. So this is called a sector. It is a fraction of the circle. Okay. Some people would call it a slice. It looks a bit like a pizza slice. And it does have an angle there. Okay. So all three of them are in there, but the correct mathematical name is a sector. Okay. Let's move on. We're nearly done, I think. What shape is this? So is this a sector, a segment, a hemicircle, or that should say crescent there? My apologies, spelled that one wrong. Here we go. Is it A sector, B segment, C hemicircle, or D crescent? And everyone's voted for segment, and everyone is correct. Well done. Doing really well. I don't think we've had any wrong answers so far today. I always think of it as like remembering the orange segment kind of thing, because it's kind of that shape. When you have a chord, it cuts the circle into two segments. You have the minor segment, which is the smaller one, and the major segment, which is what we've got a picture of here, the bigger one. Okay. So that's what a chord does. It cuts a circle into two segments. And oh, hang on. Okay, I'm going to use this word a lot today. It comes up a lot in circle theorems. This red line here, it goes past the circle. It doesn't go through the circle. It touches the circumference once and carries on. Oh no! Sorry, I hope you didn't see that. I think you did see that, didn't you? There we go. I think you would have all got it right. Anyway, I'll let you put your votes in. It's a tangent. Well done. Excellent. Okay, that was called a tangent. So a tangent is a straight line that touches the circumference once, but does not go through it. Okay, so it just has that like touch and then goes away. I'm going to use that a lot today. They appear in circle theorems. And this red line, so it's sort of a part of the circumference. What is the technical mathematical word for the part of the circumference here? Is it A, a partial perimeter, B, a semi-circumference, C, a curve, or D, an arc? Have a go. Ooh, we've got a 50% on this one. So this is called an arc. Okay, so well done. This is an arc. So a part of a circumference like this, and it could be a really, really small part, or it could be almost the whole way around. But if you just take a part of the circumference, then that's technically called an arc. Okay, so we don't see that much in circumference in circle theorems, but we do a whole section on actually finding the area of a sector and the length of an arc. So that comes up quite a lot. So you do need to know that word. Okay, so that's an arc. And that's the end of that. So I'm going to get rid of that poll. Does anyone have any questions after doing that? No, I have a feeling I've frozen, haven't I? I don't know if I can just. Have I frozen? Can you see me okay? Okay, I think it's working now. All right. So we're going to do circle theorems. So circle theorems are all about finding angles in circles, okay? So these are those questions where you get given a picture of a circle and then loads of lines and angles in the circle, and you have to find what the angles are, okay? There are lots of rules that you've got to learn with circle theorems. You need to learn how to spot those rules, so spot the different theorems, use them, and you need to learn what the names of the theorems are. Or not so much names, but there's key words in each theorem that you need to learn. So we'll talk about that today. And then in the exam questions, when you're doing circle theorems, you get marks for finding the answers. So you might be asked to find an angle. You get your marks for finding the angle, but you also get marks for giving reasons for your answers. So it's really important you do know those keywords so that you're ready to write them down when you give a reason for why you got your angle. Okay, so we'll do that today. So this is the most commonly used circle theorem, I think. And it's basically in any circle, the angle, now you don't have to worry about the word subtended, but that's the technical word. It just means the angle that comes from the same 2 points, okay, at the center is twice the angle at the circumference. So what you can see in this diagram is if we've got 2 points on the circumference, okay, P and Q, and they are forming an angle that goes to the center, and they're also forming an angle that goes to the circumference here, okay, and the angle at the center will always be twice the angle at the circumference, and it doesn't matter where the angle goes to the circumference. So if this one here is 2x, then it could be all the way over here that this one is just x, or it could be all the way over here. Obviously, we're pretending I'm drawing straight lines here, okay? This one is x. It doesn't matter where that it goes. It could even be down here somewhere, okay? Oh, no, that one actually wouldn't work because it would have to go through the line. So it could be like here. That would be it, okay? So it could go like that. So just not opposite, okay? But anywhere from there to the circumference, so that is always going to be double that angle. So that is your first circle theorem, okay? So the angle, we tend to call it the angle at the center, okay, because it's hard to remember. The angle at the center is always twice the angle at the circumference. But if you're using it in an exam, you do need to write the words center, twice, and circumference. Okay, those are your kind of key words for using this in an exam. The angle at the center is twice the angle at the circumference. If you write that sentence down, then you'll get that mark for the reason. So if this was the question in the exam, saying that this angle here at the center is 140 and asking you to find x, well, you can use that circle theorem because you can see that there's 2 points on the circumference. You can follow that angle to the center and see that the angle at the center is 140. From the same points, there's an angle that goes to the circumference, and that's the one you need. So that means that x is what? Can you write it in the chat for me? I think someone's going to write that. Yes, excellent. Well done. Thank you, Tabitha. X is 70 because it's half of this. If the angle at the center is twice the angle at the circumference, then the angle at the circumference is half the angle at the center. So x is 70, that's 1 mark, okay? And then your second mark will come from writing the sort of sentence. The angle at the center is twice the angle at the circumference. So your second mark will come from these keywords. Your first mark will come from finding the angle. Does that make sense? Yeah. Please do just pop in the chat and ask any questions as we go through today, okay? My plan is to sort of give you the circle theorems and then do some past exam style questions with those circle theorems as we go. So here, for example, is an exam style question which uses that circle theorem, but it also uses something that's really important in circle theorems, okay? Because you can actually see here that there is an angle that is at the center and it comes from 2 points on the circumference. So my instant thought is, oh, is there another angle that goes from those 2 points to the circumference? And yes, there is. So I can use that circle theorem, okay? I can use that circle theorem and I can say that this angle here that comes from the same 2 points is how big? Can you put in the chat for me? You're welcome to use calculators if you want today. Remember, this is twice this. So if the angle at the center is 2 times bigger than the angle at the circumference, try that one again. Okay, the angle at the circumference is half of the one at the center. So actually this one should be 75, okay? So what we've got there is that this angle here is going to be half of this angle here, okay? So that's the first thing. We've used that circle theorem. And if I was sat in an exam and I was answering this question, I would write down that this angle was 75. You can put it on the diagram, okay? The examiner will mark it if it's on the diagram, that's fine. But you also need to write your answer, write your reason. So you're going to write 75 and you're going to write angle at the center is twice the angle at the circumference. You're going to write all of that, okay, to get that mark. So there's a bit of writing in circle theorems. You have to do a little bit. You don't have to write in perfect sentences. You just have to get those keywords written down, okay? It can be literally that, okay? So that's your first part, but you've not actually found out what x is because x is only a part of that 75. So you need to use what I think is the most important rule on circle theorem questions, and one that a lot of people easily forget. How can I find this? Has anyone got any thoughts on how I can find this angle here, this one in red? What can you spot about that? No? Okay, that's fine, because that's what we're doing today. The most important rule is that this is at the center. Okay, so this isn't a circle theorem, but this is probably the most useful thing you can learn. And if this is the center and this goes to the edge, and this is the center and this goes to the edge, what are these two lines? What are they both called? And in fact, this one here as well, this one goes from the center to the edge. They're all called the what? I know you know it because we just did it. They're called, what's the name of the line that goes from the center to the circumference? Radius, yeah. Those are all called radiuses. That's a radius, that's a radius, and that's a radius. And if they are all the radius of the circle, they are all equal lines, okay? So the first thing that I think you should do in any circle theorem question is find any radiuses, find the center and find any lines, straight lines that go out to the circumference. And if you just put that one mark dash on there, I think you've seen that before. That's a way of marking equal length lines. Have you seen that before? You can mark equal length lines using a dash. Now that I've put those two dashes, what do you notice about this triangle? It's a special word for that triangle. Isosceles, excellent, well done, okay. So if it's isosceles and this is 60, what's this going to be? $60. Okay, so now you can see how to find x, hopefully, can't you? Can you see how to find x now? Because we know that all of that big angle is 75, and we know that this little part here is 60. So x is going to be equal to 75 minus 60, which is 15 degrees. Okay. Happy with that? Does anyone have any questions on that? Okay. So with all circle theorem questions, okay, my big sort of hint that I'm going to put up, my circle theorems hint number one, the most important thing is to look for radii, that's the plural for radiuses, okay, and mark them on the diagram as equal length, okay? So you're looking for, I can see 3 radiuses on this diagram, okay? If I mark those radiuses, radii, as equal length, I can instantly see, well, this is an isosceles triangle, so that must be 60. This is an isosceles triangle, so this angle must be x, okay? So I can instantly start to work out these angles. I know from there, that's 60 and that's 60, they add up to 120. I can work that out because they're in a triangle. Okay, I can work out that, and then I can work out. So there's lots of ways. I mean, I didn't need to use that method because I could use that circle theorem method, but there's lots of ways. You can always get to your answer, even if you can't quite remember one thing. You can usually get to an answer with angles by just doing all the angles you can. Okay, if you mark everything on you can, you'll get there eventually, even if you have to do like a few extra than you needed to. Doesn't matter as long as you get there. Okay, so there's always a different way around it, or usually. Okay, so that was circle theorem 1. Although we don't really name them because they don't actually have, sorry, we don't number them because they don't actually have numbers. I once, in my first year of teaching, I taught all the circle theorems by being like, circle theorem number 1, and then taught it. And then when I came to mark the test, all my students had written their reasons as circle theorem number 1. And I was like, oh no, what have I done? So they're not numbered. But here is an exam question using that theorem, okay? Took me a while to spot this actually, because it's hard to actually spot that, like that one's at the center and that one's at the circumference, okay? So what we've got here is we've got P, Q, and R. P, Q, and R are points on the circumference of the circle with the center O, okay? PO is parallel to QR, so this is parallel to this, and POQ is 48, so that is 48. You are asked to find angle OPR, so obviously we're going to draw on the angle that we are asked to find. So that goes from O to P to R. So it's that one there. Okay. So that angle is the angle we need to find. We've got 2 radiuses. We've got a radius there and a radius there, but that won't help us too much because we don't really have a triangle to use there. Okay. But what do we have? We've got this angle POQ. And we know this angle, we can find PRQ. Can anyone write what PRQ is? Can anyone spot using that circle theorem that we did? I hope you can see, can you see it clearly? It's not 48, because remember, this is at the center and this is at the circumference. They're not the same because the angle at the center is twice the angle at the circumference. So just be really careful with that one. So if this angle is at the center and it's 2 times bigger than this one at the circumference, they come from the same points, don't they? So this angle here must be 24, well done. Okay, so that angle is 24. So we're getting closer. We've actually got 1 mark there by writing that angle down as 24. Okay, the angle at the center is twice the angle at the circumference. There we go. Doesn't help us though, because this is the angle we need. But we can work out another angle using this. PO is parallel to QR. We did this a while ago. We did our parallel lines. It has been Christmas and New Year. We did learn that in a whole different year. This line is parallel to this line. So what can you tell me about this angle? What's that angle? Now it's 48, well done. So that angle is 48 because of parallel lines, all right? So we've got that one is 48, that one is 24. Now we can go ahead and we can work out which angle. Well, we can work out I'm going to get a different color. This angle, using our angles in triangles, okay, because they're all in a triangle now. Who's going to work out that angle for me? Ooh, it's just occurred to me. We can get to the answer. Oh, well done. Brilliant. 108. Both of you are there. That one is 108 there. Okay. Now those are vertically opposite. So that's 108. And then finally, what's this one here? This red one. I've just realized that we could have done this a quicker way. P equals 24. Fabulous. Well done. Can anyone spot the quicker way that we could have done it? Because I did this 48 and this 48, but of course, if they're parallel, we'll go back to my purple parallel lines, then this one must be equal to this one because they are also alternate angles on parallel lines. So you can hopefully see from that there's always a way to get there. Even if you don't instantly spot the quick way, you can find other angles and you can get there by using the kind of a longer route round, but you can always get there, okay? So you can find your way to the angle you need. The best thing to do with angles like questions like this is just to kind of fill in all of the angles you need as you go, okay? Anyone got any questions about finding that answer? Right, so let's move on. I think we're going to do 2 lessons on circle theorems because they are long. There's quite a lot on them. And Edexcel IGCSE has a whole extra circle theorem that doesn't even use angles, it uses lengths that the other exams don't have to do. So we'll do that next week as well, okay? Now, this is another circle theorem. It's a special circle theorem. It's actually generally a special case of this theorem because the angle at the center is always twice the angle at the circumference. So if this is the angle at the center, but it's 180 because it's a straight line, then the angle at the circumference will be 90. Okay, so if the angle at the center is 180, that means that the line it's sort of formed by must be a diameter. So that means that if you have a semicircle, you've got a diameter and it forms a triangle like this, where one angle is at the circumference, then you're going to have a 90-degree angle. You're going to have a right angle in there. Okay, so that's a kind of special case, very useful, comes up very often, so definitely worth being aware of it and looking out for it. Okay, and I'm going to have a look at doing this question here. I think I'm just, can you hear me okay? I can see you, but I think my camera's not working so well. I apologize. I'll just carry on, and if you can't hear me for any reason, do just write into the chat and let me know that I'm not clear, okay? So we are asked to find here angle DBC. Let's have a look. That's D to B to C. So in this question, we're looking for this angle here, okay? And what do we know? Well, we know that we've got the center O and we've got a diameter going straight through the center, okay? So we know that this angle ABC must be a right angle, because if we have a diameter and we have the ends of the diameter forming an angle at the circumference, then that is a right angle, okay? So we can put that right angle in there. Anything else that we know from this? Who can tell me what this angle here is? ACB. I'm going to write this down as though we were in an exam. We're doing our proof. So I'm going to use the angle ABC is equal to 90 degrees. And I could write there angle in a semicircle equals 90 degrees. Sorry, yes, if you're using that circle theorem, the key words that you need for your reasons are angle, semicircle, and 90 degrees, okay? Or angle, semicircle, and right angle. So you would need to write that down. You've got 1 mark there, you've got 1 mark there. So, oh, someone's given me 65. Is that for this angle here? Yeah, great, thank you. So we've got angle. Let's have a look. That's A to C to B. ACB equals 65. And the reason there is that the angles, oh, so you do have to give reasons all the way through. I don't know why my pen isn't working though. Okay, I'm just going to tell you the reason. Angle in a triangle add up to 180. Okay, so angle, triangle, 180. Okay, so well done. You've noticed that 125 plus 90 is 115. You've subtracted that from 180 and you've got 65 there. Okay, brilliant work. Now, what else can we find out? We can find out, let's have a look at this little triangle. We can find out this one now, because we found out that that's 65. We can use this little triangle to find out. Oh, no, we don't need to use the little triangle. We can use this 100 and the straight line to find out this one. So angle, oh, that's called BEC or CEB. Doesn't really matter which way around. Okay, is equal to what, please? 80. Excellent, brilliant. Angle on a straight line. I'm not going to write that down, but you would have to write that down in an exam. Angle on a straight line equals 180. So now we've got that one is 80. Okay, and finally now we can work out what angle DBC is. So it's quite a lot. We have to go through quite a lot of like finding other angles. You can't just get straight to the angle you need. You have to kind of use everything you know, but we can get there eventually. So DBC then is 35. Thank you both. You got that really quick. Well done. 35 degrees there. Okay, and that again, so that would be angle DBC is 35, and again you've written angle in a triangle as equal to 180, so that's done. So a lot of work there to get that angle you needed, but hopefully you're starting to see how these circle theorems questions sort of work. You have to work your way through as many angles as you can to get there, and you will get there eventually. Okay. Right, so we've done, oh, here we go, circle theorems, hint number 2. If the question has a diameter, so if you spot that there's a diameter on the question, start by looking to see if that diameter forms a right angle and mark those right angles on. So on this question, the first thing we did was we went, okay, well, there's a diameter here. And from that diameter, we've got this angle. That's a right angle. There's no, we can't do that with this one because this one isn't a diameter. DB is not a diameter. So I can't look at that and say, well, that's an right angle because it doesn't go through the center. And I can't do it with this. I mean, I've not got an angle here, so I could make an angle here. I could actually join that up with that and say that that was 90. Sometimes in really tricky questions, you do have to like add your own line in. So if you're really struggling, but you see, oh, well, if I add that line in, I've got 90 there, you might be able to do something with that, okay? So sometimes you might draw a line in, but generally try and just add your 90 degrees in when you can, okay? Only though from a diameter. If the circle doesn't tell you that the line is a diameter and you can't see the O to tell you it's in the middle, don't assume it's a diameter, okay? Sometimes there might be cheeky questions where you've got a circle and a line and you think, oh, that must be a diameter. So and then I can put that right angle on. Oh, that should go to the circumference. Sorry, that was really bad. But if you're not told that that's going through the center and, you know, you're not told it's a diameter, you cannot just assume that it is, okay? So just do check first that it is actually a diameter before you use that circle theorem. Okay? Any questions? Okay. So, oh, I told you we'd be doing lots of work with tangents today. So tangents. We have two circle theorems of tangents. I put them both up here, okay, because they tend to quite often be together. The first one is that in any circle, a tangent will meet a radius at 90 degrees. So your key words here are that the tangent meets the radius at 90 degrees. So with this one is another one that is really common. If you've got a tangent to a circle and a radius at, like, it meets a radius like this, then you can always put that right angle on there, okay? So if we had another oh gosh, that was just awful, wasn't it? We had another tangent here, that was just as bad because it doesn't. Here we go. If we had another tangent here and a radius here, that meets at 90 degrees, okay? So anywhere, it doesn't matter where on the circle, if it's a tangent and a radius, then that's a 90-degree angle, okay? And then another circle theorem that comes from tangents is that two tangents that come from the same point, so the same point, that's a key word, outside of a circle, and then they meet the circle at the 2 points on the circumference like this, then they're equal length. So you can see these dashes here to say that they're equal length, okay? The reason why there's two dashes on them is because these are radiuses, so they're also equal length, okay? So you've got this lovely kite that's formed by two tangents meeting a circus like this, a circle like this, where you've got two radiuses, so they're equal. You've got two tangents that both come from the same point and meet the circle, so they're equal. You can say from this circle theorem, a tangent will meet a radius at 90 degrees. There we go. Okay, so you've got this lovely, and actually that now is a nice symmetrical kite, isn't it? Because you can see that that is basically got a line of symmetry down the middle there. Okay, so it's two triangles that are exactly the same, congruent. That's the word for that is, okay. So sorry, this is a lot of information, isn't it? I know that's a lot of information. If you've got any questions, do ask, or if you just want me to slow down a bit, do let me know, okay? Let's have a look at some of those questions in practice. Here we have got, okay, so we have got a circle. We've got a tangent meeting circle there, and we've got a tangent meeting the circle here, okay? Now, the very first thing you should do if you see something like this, you spot those radiuses. My hint number one was always put marks on the radiuses to tell yourself that they are equal length, okay? You could also put marks on these tangents to tell yourself that they are equal length, okay? I've done both of those before I've even really read the question, just because they might be useful. For this particular question, we're looking for the value of theta. So we're looking for the value of this angle here, okay? So I'm going to think, wow, how am I going to find that? Oh, that's the third hint that I didn't do there. What's this angle here? This is a radius, this is a tangent. What's the size of this angle here? Who can tell me what angle ORT is? 90 degrees, brilliant. There we go. What's the size of angle OST? 90 degrees, brilliant, well done. They are both the same, okay? So we've got 90 degrees there. I've put right angles on, but I'm just going to write them as well. Just makes it easier to spot. 90 degrees there, okay? You can tell me what this angle is. Bonus points if you can tell me why. 25 degrees. Great, well done. Quite a long reason why, but they are vertically opposite angles, okay? So that's vertically opposite to that, okay? So now, in this quadrilateral, we've got 3 out of 4 angles. Who can remember what the angles in a quadrilateral add up to? 360, good. So a bit of maths to do. Tell me what the answer is. So we've got 3. We can write it down, 90 plus 90 plus 25 plus theta equals 360 degrees. Fabulous. That's the same as what I got. Brilliant. So theta equals 155 degrees. Okay, so there we go. 155 there. All right. So that is an example of using those two tangent theorems together. Okay. Are you happy for me to move on, or does anyone? Yeah. Like I'm just throwing circle theorems at you today. So if there's a tangent, check to see if it meets a radius and mark that right angle. So here, that's what we did, isn't there? If there's a tangent there and a tangent there, check to see if it meets a radius, and if it does, mark on the right angles, okay? If there are two tangents from the same point, mark them as equal. And that probably would have been really useful. It's most likely that the next question, once we found that, would be to maybe find like the area or something of the triangle, or the area of the shape, okay? So you could then, knowing that they're equal, knowing that everything is congruent, you could then use that fact. So that is really a useful thing, okay? Right, you ready to learn another circle theorem, or do you want to leave it there for now? Let me know in the chat how you're feeling. I've just given you a lot of information today. So no one's answering. Okay, well, I will introduce this last one. And then hopefully we'll just do some sort of exam style questions on what we've learned so far. So here is a new word for you, okay? I don't know why I put a capital O there because there's a comma. I'm sorry about that. Bad grammar from me today. But in any circle, opposite angles in a cyclic quadrilateral, maybe pronounced cyclic quadrilateral, I use cyclic, add up to 180 degrees. So most important thing that you kind of can recognize here is a cyclic quadrilateral is a quadrilateral that is what's called subtended in a circle. So it is all 4 corners of the quadrilateral must be on the circumference. So this is a cyclic quadrilateral. This is a cyclic quadrilateral, okay? Just be really careful not to mistake things that are not. So if you've got a circle like this, imagine that's a better circle, and you've got a quadrilateral like this, that is not a cyclic quadrilateral because it only has 3 of its corners on the circumference, okay? One of them is at the center. Really easy mistake to make. I still make it all the time. I still go, oh yeah, well, they add up to 180, but they don't, because that is not on the circumference, okay? So just be aware of ones that might look like cyclic quadrilaterals, but are not. They will be thrown into the questions. Be careful, okay? So keywords are cyclic quadrilateral. You need to remember that word. Opposite, because the opposite angles are the ones that add up to 180, okay? So A plus C equals 180, or B plus D equals 180. It's a really useful theorem, helps us find lots of angles, but you just got to remember opposite angles, okay? So here's a nice simple one. This is a cyclic quadrilateral. All 4 corners are on the circle there, okay? So who can tell me what X is? And I'm not sure it's very accurate. Oh, I suppose it is probably. What's X? Excellent, well done. Yeah, really quick. So X plus 130 is equal to 180. So 180 minus 130 is 150. Okay, great. Unfortunately, in exams, they're not always that sort of easy to spot. They're usually a bit more hidden. Here's an example of an exam question. Okay. Not as quick and easy to spot, but you can definitely spot quite quickly that that is a cyclic quadrilateral, can't you? Hopefully you can see 4 corners and they're all on the circle. So that's the theorem we're looking at. We can't find Y straight away. F, G, H, and J are points on the circle. E, F, G is a straight line parallel to JH. So E, F, G is parallel to JH. Find the value of Y. If anyone wants to can anyone spot what that is? Got 2 things to do here. You can't go straight to the answer. Okay, no answers yet, but can't go straight to the answer, but I can see, oh yes, excellent, well done, fabulous, really well done. So I can see that, oh gosh, what have I done? This is opposite to this, okay? Oh, there we go. I can see that, so let me just get that, and then that won't happen, okay? So I could think to myself, oh, if I could find out that, I can find Y. Okay, so that's one way of doing it there. And actually that is the way that I did it. Okay, because then I thought, oh, well, I've got this is parallel to this. And so these are parallel lines. So I can now go to my parallel line knowledge. I can see that these are what type of parallel line angles? Can you remember the name? It starts with an A, L, T. I'm just going to write it, alternate angles. So if you were asked to give reasons for this, you'd have to write down alternate. So now you can say that that's 108 degrees. And then yes, you can do what Favors said in the chat there, 180 minus 108, because those two add up to. So Y is equal to 180 minus 108. And that is 72. And then your reason, cyclic quadrilateral. Okay, so you do need to write that down. Okay. I am going to find hopefully some questions. I might just leave that one to next time. Although I think we need that one for this one. So maybe we can do that one quickly first. Okay. Well, we will actually, first of all, could I ask you to find this angle for me? Okay. So in this example, what is this angle here? X. We will find theta as well later, but that involves one more theorem. But you can definitely find X for me now. This can be your sort of nearing the end of the lesson. It's not 90. This one is actually 90. Because that is a diameter and they create, there is the semicircle, the angle in the semicircle. So this one is 90 here. And this one is 90 as well. Okay. And so you can see you've got two 90-degree angles there. Opposite angles do add up. Almost. Oh, unless I've just done my maths wrong there. Let me just double check mine. Okay, no, I think just try that maths again. I think your method was right. So we have got, yeah, excellent. So we have got 73 plus 14 plus 12. So this whole thing here, okay, 73 plus 14 plus 12 is equal to 99, isn't it? Okay, so this whole thing here is 99, but I've asked you to find this angle, and this angle is opposite it in a cyclic quadrilateral. So what's that going to be? Fabulous, well done. Okay, so it's actually going to be 180 degrees minus 99 there. Okay, so that one is 81 degrees. All right, well done. Okay, so you do kind of have to do a little bit. And I'm going to go back to the question, the theorem that we did right at the beginning, because that does just introduce this last theorem. So this theorem here. Okay, so the last theorem we needed for that question. This theorem here, can anyone remember this theorem? I hope you can. This is the angle at the circumference and the angle at the center. The angle at the center is twice the angle at the circumference. And what I did earlier to try and explain this is that I showed you that any angle that comes from the same 2 points that meets the circumference there is always going to be half of that angle at the center. Ooh, bad drawing. It's going to be half of the angle at the center, basically. So if that's 2x, that's x. Okay, if that's 2x, that's x. And if that's 2x, that's x. And that means that these are all exactly the same. Okay, so that's going to be one more. That's the last theorem I want to leave you with today, which is that any angle that meets the circumference, it could be any angle, it could be one here as well, okay, that come from the same 2 points on the circumference. There's an x as well, okay, they are all the same. So that's kind of the proof of it. So let me just go back to the theorem and show you it, and we'll use it. Maybe. Okay, so here we have a better drawing. So in any circle, any angle is called in the same segment, okay? Because do you remember the word segment that we learned earlier? They're angles that are cut by a chord. Ooh. We'll come back to that one in a minute. There we go. Okay, so if this is a chord, oh, I really need to buy myself a new pen, digital pen, don't I? This one's rubbish. So this is a chord, and this x is an angle. Can you see how this x is the same? It's exactly the same angle. It comes from the same chord. Okay, so that's why it's called same segment theorem, because they're in the same segment. And so it's a bit tricky to spot this one. You kind of need to do a bit of practice. One thing that I suggest as a way to sort of try and explain how to spot this in an exam, it's a bit hard to do on the computer, but if you've got an angle at the circumference like this, I always suggest getting your fingers and actually just drawing the line. So 2 fingers following those lines down through the circumference. Okay, so there. So you can see the 2 points on the circumference that angle comes from. And then from those 2 points, look to see if there's any other lines that go in a different direction. So you can see these 2 lines here that go in a different direction, okay? And you know that those angles are the same. So it takes a bit of practice. You actually need to get your paper, get your fingers, and actually draw that, like imagine sort of drawing the lines with your fingers on. Let me just go to, oh, well, I can just, with this one. So this one here, I can see this angle is 50, okay? So I'm going to actually get my fingers, and I'm going to sort of imagine drawing with my fingers a line down to where that angle came from. So it came from this point here and this point here. So that's where my fingers will be right now. And then I'm looking for other lines. So lines that my fingers haven't just drawn down. So that would be these 2 lines going this way and this way. And I know that because they come from the same points on the circumference, they must be equal angles. So that tells me that x is equal to 50. Okay, takes a bit of practice, that one. So I'm going to leave that with you, and you can hopefully go away and practice a few questions. But just spotting that one is a really useful thing. Let's quickly move on. We've got 3 minutes left, and I'll just go back to this question that we did. I wanted you to actually find this angle, theta. Okay, so this is the angle I wanted to find. So I'm going to put my fingers on that, and I'm going to draw my 2 lines. I'm going to draw a line down here. Obviously, with your 2 fingers, you can do it at the same time. I can't because I've only got 1 pen down here. So I found that that angle is formed by these 2 points. Okay, so now I'm looking for 2 different lines, and I've got 2 different lines. I've got, let's get a different color. I've got this line on this line, and I can trace that point up. Oh. And I can say, well, theta, is equal to this. Okay, so this is also theta. Doesn't actually answer my question right now, but I do know that that equals that. And I can find this theta out because I know that that's 73. I know that this is 90 because it's an angle in a circumference in a semicircle. So that's 90 degrees. So although I couldn't find this theta, I can find this theta, and I know that they're the same. So just before we go, can anyone tell me what that theta is? Brilliant, well done. Okay, so in the triangle there, we've got 73 and 90. 90 plus 73, which was 163, and then subtract that from 180. 17. Okay, so theta equals 17, and because they're in the same segment, because that and that are the same, that theta also equals 17 degrees. Okay. Right, that's been a lot of information. I do apologize for how much I've tried to sort of throw at you today. I'll just put my video back on. So I know that I've thrown a lot of information at you today. What we'll do is I'll give you your 2 weeks to go away and digest all your circle theorems. And then when we come back, we'll do some kind of exam style questions and just practice using them. Okay.